So now we need to write an exponential function that goes through the point 1, 9, and 227. What I'm going to do is make a table. And remember, our initial value is going to be when x is 0. So I'm going to put that. And if x is 1, we're at 9. And if x is 2, we're at 27. Now, exponential functions multiply to get to the next number. So to take 9, what do I multiply to make it into 27? And that number is 3. So I know that my growth factor is 3. And we're looking for our initial value. So to move down the table, you would multiply by 3. Like 27 times 3 would be 81. So to move up the table, we divide by 3. So what I do is take 9 divided by 3, and I get 3. So my initial value is 3. So my equation then, remember an exponential equation is y equals a times b to the x. And in this situation, that would be 3 times 3 to the x. So now to write an exponential function that it has 0, 3, and 1, 4.5, my initial value here when x is 0 is 3. And then to find my growth factor, I would take 4.5, the y value, and divide it by 3. And that's 1.5. So to write my exponential function, it'd be y equals 3 times 1.5 to the x. So now Brittany is doing a science experiment with bacteria and has noticed that each week the number of bacteria triples. So right now I know that b, my growth factor, is 3 because tripling means multiplying by 3. So she started out with 4 bacteria colony. That tells me my initial value. So A equals 4. So write an equation that can be used to calculate the number of bacteria that colonies have that Brittany has after W weeks. So here we can just say y equals 4 times 3. And then here, instead of using x, we're using the variable w for the number of weeks. So now here, you deposit $200 in the bank. So our initial value is $200. Now an interest rate is 4%. So to turn that into a growth factor, we take 100% and add 4%, which is 104%. But this is a percent, and that means we need to divide that by 100. So to divide that by 100, you can either do 104 divided by 100, or that just means you slide the decimal point 2 spots to the left. So my growth factor would be 1.04. So in order to make our function, we would go y equals 200 times 1.04, and then to the x, but in this case, we're trying to find how much money is there going to be after 12 years. So I'm going to put to the 12th. And then you plug that in and go 200 times 1.04, and then to the 12th. So that's going to be 320.21. So in looking at this table, as x increases, y is decreasing, and it's not linear. So let's make sure it's exponential. So I can go 12 divided by 15, and I got 0.8. So if I do 12 and then divide it by 15, that gives me 0.8. And I'm just going to check another value, 9.6, and divide that by 12. And that is also 0.8. So my decay factor is 0.8. That means I'm going down. And my initial value, A, is the value when x equals 0. We have 15. So my exponential function would become y equals 15 times 0.8 and then to the x power. So here, if we are creating a value here, we have to figure out, well, what are we multiplying by? So 36 divided by 18, that's timesing by 2. And same thing here, 36 times 2 is 72. So b is equal to 2. Now, if we want to find our initial value, we need when x is 0. So if I take 18 and divide that by 2, that gives us 9. So a is equal to, if I did the value 18, divided that by the growth factor of 2 and get 9. So my exponential equation, remember that's y equals a times b to the x, or here 9 times 2 to the x. So we're going to continue here, and we're going to identify the factor, the asymptote, and the y-intercept for each of these graphs. So to find the factor, you can take b is equal to 0.648 and then divide that by 0.36. And that gives us 1.8. And then here, we need to find the y-intercept. So if you look here, if I multiply by 1.8 to move that way, we can move backwards from 0 and take a is going to equal 0.36, and we can divide that by 1.8. And that will give us our initial value of 0.2. So that means our y-intercept is 0 for x and 0.2 for y. And then if we were to graph that, so if we look for our asymptote, we have 0.2 or 0.2 times 1.8 to the x. And if you notice, this asymptote is at y equals 0 because the equation would be y equals 0.2 times 1.8 to the x. And if you notice, there's no constant being added here. So this would be plus 0. So that means my asymptote would be at y equals 0. So now in this situation, for this one, we have to find our y-intercept. And that is the point 0 for x and 10 for y. And then to find our growth factor, we have to find another point that is clearly labeled. So I'm going to use this point right here. Or we can use this one here too and just say if x is 1, y is approximately 12. And then get a growth factor. So b is going to equal 12 over 10, which is 1.2. So then our equation would be y equals 1.2, or 10, I'm sorry, our initial value. So 10 times 1.2 to the x. And then if you notice here, we also have an asymptote at y equals 0 because the y-intercept would be of this, or the part we would have like a plus 0 here, which is not the y-intercept here, but means that we would have like the plus 0 would tell me what the asymptote line is. So the asymptote is y equals 0. So now on here, it says, what transformations would change the graph of f of x equals 3 to the x to the graphs below? Now, what I want you to notice here is we are multiplying this equation by 0.5. So this would actually, if I look at, and I were to graph y equals 3 to the x, and then also 0.5 times 3 to the x, and then plus 2. This graph becomes what's called a vertical shrink because it's being multiplied by a number to be smaller. So this makes what's called a vertical shrink. And when you multiply the front part by a fraction, it's called a vertical shrink. If you multiply it by a number that's bigger, it's going to stretch it. And then this plus 2 moves the function up 2. So that's just a translation that moves it up 2. Same idea here. If you look here, and we did this negative 3 times x to the minus 1. So I'm going to clear this out. And we did negative 3 to the, and I put in x minus 1. This is going to shift the function. So if you notice, it moved it to the right. So that moves it to the right one spot. And then that negative button, or the negative in front of it, is a reflection over the y-axis. So here, we multiplied the function by 4. When you multiply in front of it, it's going to be, and you multiply it by a number bigger than 1, it's called a vertical stretch. And then this, the minus 5, moves the function down 5, or it's a translation of down 5. So I can take the y equals 3 to the x and put that in there to show you. So 4 times 3 to the, I'm going to delete this, x minus 1. So 4 times 3, to the x. Delete that out and then put minus 5. So if you notice, what happened, we stretched the function, and then we also moved it down 5. So now we're going to have to write an equation that has these transformations. So 7 to the x. We want a reflection. So I'm going to put f of x. To make a reflection, we would put a negative there. And we want a horizontal translation left. So to do a horizontal translation to the left, you subtract the x value. So I'm going to put with an x value here. And then to move it left, I'm sorry, I misspoke there. I would add, say, 2. And then to move it down on the end of the function, I would move it down, say, 3. So I'm going to subtract 3. So to show this to you, what I'm going to do is graph this function. And I'm going to have the y equals 7 to the x. and then put in my function. So negative 7 to the x plus 2. And then here you're going to subtract 3 and then graph it. So if you notice, it moved to the left 2, got reflected, and then it also moved down 3. So we now want a vertical stretch. So to stretch it, you multiply the number by a number bigger than 7. So I'm going to go, let's say 3, and then times 7 to the x. And we also want to move it up. So I'm going to add, let's say 4.